Hey guys, John Grimsmo here. Figured I'd throw a little vlog together for you guys today. Almost didn't. Okay, one thing we're working on right now in the Mori is we're bringing back a pattern, a knife pattern that we did quite a while ago called the Starburst pattern. And we tried doing it before a few months ago and it didn't work out. There was a stupid line. I got annoyed with it. I'm like, don't do it right now. But I was talked into redoing it, and I'm glad I did because it's coming together great. But there's some problems, so let me explain that. So with CNC machining, there's this classic aspect called climb milling versus conventional milling. And when we're doing the Starburst pattern like this, can you see? I need a pointing device. Ha-ha, Grimsmo Saga. Okay. On the left side of the wall, it looks amazing. On the right side here, it looks all chattery and gross. That is because the direction that it was going in, the left wall got climb milled, and the right wall got conventional milled, because I'm literally just dragging the tool across like that. So one side is getting, I guess we're going in this direction. One side is getting conventionally milled, which is, climb milling. When you're machining the outside, climb milling is always clockwise. When you're machining the inside of a circle, climb milling is always counterclockwise. And for the most part, carbide in metal, you almost always want to go climb milling. So clockwise on the outside. So if I'm going on the outside of the fixture, I'm going clockwise. But if I'm going inside of a little hole, I want to go counterclockwise. And that is climb versus conventional milling. Because you get this grossness, you get this bad finish. So I'm reprogramming the toolpath right now to, I'm gonna try to just do one pass and then move it over ever so slightly and do the other pass in the opposite direction. I think that should clean it up. When we do our Dimond handles, like this bad boy, this is knife number 1. This is Norseman number 1. Actually, Norseman number prototype 0 also has diamond pattern. This is the first pattern we ever did. And I figured this problem out way back then because it's used a 1/4 inch ball mill and it's just plowing through this titanium. So one wall's gonna look good, the other wall's gonna look bad. So when we make this pattern, I have the ball slot through it, and then I have it move over 1/1000th of an inch and do that wall, and then move over 1/1000th of an inch the other direction, and then do that wall for every single slot and arc. And you can actually see that where the pattern is in this. It's this concentric series of circles and rings. So for this one, the origin's about up here, and then for this one, the origin's about over here. And it's just these loops and loops and loops. So yeah. Fun fact about climb milling versus conventional milling when making a cool pattern. Also fun fact in my little goodie drawer, a couple years ago I got to tour Kenny Palco's prop making shop. He does props for movies. This is a bullet casing for a 50 caliber Desert Eagle pistol for Deadpool 2. So Kenny actually made the handguns for Deadpool 2. And he engraved, I don't know if you can see it, KP DP2 Deadpool 2. So he took actual Desert Eagle guns and disabled them, made them shoot blanks, but not before he got to take them to the range and play with it a little bit. Fun little fact. Quick screen grab here. So that's what the toolpath looks like. And actually, I believe this is both of them. So if we go way out to the back here, you can see I have 2 lines, because I spaced them out 0.05 degrees difference. So there's 2, I've got 2 little eyeballs on here, 2 tool paths. One is here, and the next one is 0.05 degrees shifted. And yeah, you can see the 2 little lines. So I think this will work. One of them goes center out, the other one goes out center. And that should solve our little problemo there. So I'm gonna redo that one that's on the machine right now. I'm gonna recut it with this, and then we'll see how it works. One more quick thing on that. So I was saying before that when we did this pattern a few months ago, there was an issue that I didn't like. And I figured out, now that I looked at the toolpath, I've been avoiding it, I figured out what the problem is. So the rendering looks not great here, but there was this extra line here that was very visible in the finished knife. And like, this animation is gross. It's not normally that chunky, but there was a line here that looked stupid in person, and I didn't like it, and I couldn't polish it out, and had to figure it out. So I gave up on the Starburst for now. But I figured out what the problem is just by looking at the toolpath. So the very first cut is... well, this is the new one, but the very first cut is basically that. It's one heavy line dragging through thick material, cutting on both sides, and then after that, it's basically only cutting on one side, and it's got light cuts all the way around. But that first drag, that was the problem. So I created a little clearing operation where if I not generate, give me a second. If I simulate that, so the clearing operation basically just clears out a little bit, like 9 degrees this way and 9 degrees this way. And then the next toolpath can come in, and I gotta skip ahead a bit. There. And start doing light, easy cuts with 1 thou of floor left. Easy peasy. Check out this quick little hack. Some of you might not know this. So you select 2 operations or more, whatever you want. You go right click, compare and edit. This compares the one options with the other options, and my favorite is to go down here to different. These 2 toolpaths are almost identical, but except for the few little differences. So we have 0 to 360, and we have negative 0.5 to 359.95. And we also have other way and one way. These are the differences between the 2 toolpaths. And sometimes I'll edit the code right from here because it lets me see things. So we ended the last video with me being super duper frustrated with the whole process of it wasn't making sense. And it stayed that way for quite a while, but I have just figured it out. I think it was just some, I don't know, I wasn't thinking properly. Some settings between here and there and work coordinate here, and it wasn't making sense, but it works great now. So let's make some parts. So while that's running, almost done. One thing I want to practice with today is I have 2 vices. I want to load up 2 vices of parts. I've got a lot of parts to dovetail right now. It's working great. I want to teach the machine how to machine one part while I'm loading the next, and then this one's ready, and then that one runs, and then they switch back and forth, so that while one's running, I can load the next one. And the learning curve for this is very short. Like, I just have to write a program. I think I know how to do it. But that's kind of what I'm working on right now. So I just unbolted these 2. This jaw, if I can do it with one hand, comes off. I'm going to flip it the other way around so that it matches the other vise, because I had this in an ID gripping scenario, and now I want it to be an OD gripping. Okay, so I'm going to clean that up, make it nice, put it back together properly. Got it. Okay. I was curious about that because when it was cutting the dovetail and it cutting around the outside, one side was cutting air and then the other side was cutting chips, and I was like, it should be centered. Why is it not centered? I figured out why. So you can see this side is shallower and this side is deeper. Like quite a bit actually. This side is way more in towards center than this side is. That's relatively bad. Let's not keep doing that. And it took me a second, but I figured out why. Because the way that I mounted it in the dovetail jaws, just kind of threw it in there. This bottom surface is a saw cut surface. Just like this side, just like that, just like the top side. And I mean, these saw operators are not the most square, critical, tolerant kind of perpendicular squareness. So it's actually tilted to the side 1 degree, 2 degrees, I don't care what it is, it's bad. So I can't do this. I can't throw it in the jaws like that. So what I'm going to do is next time I'm going to drop it down into the flats here so that the flats of the vise hit the flats of the side. I'll see if I can get away without using a parallel to space it up, but if I have to, no big deal, and that'll be the new plan. Let's program that up. And in case you're wondering why that's bad, if this is the part that I'm making and the tool's going to come in, and the tool's going to come in, and it's going to flip this way, and then it's going to flip this way, your flip on a 5-axis machine needs to be on center line, because in the computer it thinks it's on center line, but now I'm putting a variable into the system that the computer doesn't know about. So instead of rotating perfectly on axis, it's flopping like this. So this side might cut air, but this side's going to cut heavier and heavier, and that's bad. I mean, if I have to, I'm fine scrapping that part, but I'm just going to flip it over and machine dovetails on the other side, and then there's plenty of material. Yeah, I can save that part. I'll just flip it over and do it again. Done. Meanwhile, I'm recutting the starburst pattern. It's been going, it's been going 27 minutes already. A bit longer than I expected. We'll see how long that takes. And also been cranking out bearings. Whoa, look how gross this thing is. It's like I don't know. It's a mess in there. But it's been super reliable, super awesome. I got just a couple in here right now, but check this out. So many. I haven't told you about those ones. I made a quick post on Instagram. So these guys are for, I'm going to show you. If you're not excited yet, get ready. I talked about this, I don't know, a few videos ago. This, drop it. This is our, I've been calling it this since 2012. It's the 3-inch integral. It's going to have a 3-inch blade, 3D printed prototype. Literally, this knife is 7, 8 years old. It's crazy. This guy's going into production hopefully by the end of the year, end of 2020. We'll see. I keep thinking about it. I keep making progress on it. Anyway, these little bearings are just a variation of our standard bearings, but they're going to go in here. And I need this weird size with a huge pivot bore, just due to the way the geometry of an integral works. This is one solid piece of handle that's going to be cut, a slot where the blade goes, and then no screws attaching two handles together. This is one handle. Really cool. I've been excited about this for 8 years now. And not that I needed the Kern to do it, but holy heather, the Kern is going to be amazing to do it on. I could absolutely make this on the Mori, I just don't want to. The way I want to make it is on the Kern. So I feel like the past few days for me, I haven't filmed much. They've been challenging, frustrating days. Like little things, nothing big. Today I feel like I'm winning. I feel like things are going really good today. Got a lot of things going on. The other guys went to go mountain biking today for the afternoon, so I've got the shop to myself for the last few hours of the day. And I just feel like I'm winning. It's good. It's a great feeling. So here I'll give you a kind of a preview of what the Dovetail would it be doing here. So as I tighten it up, you can see how the grippies on the black vise body, jaws, just secure right into that dovetail in the fixture. This thing's not going anywhere now. It's held laterally, you know, in this perspective, front to back, by the grippiness and just the interference fit. But your tipping nature is hugely stronger, and it's not going to pull out vertically unless it breaks. But yeah, cool. It's an extra step. It's a process. There are devices. Lang has one called the stamping device that uses a hydraulic thing to like stamp that jaw pattern into it. Sounds awesome. I don't know how much they are. I think they're probably a few $1,000s. If you're doing this a lot, I've heard from a lot of guys that have it. They're like, oh, don't cut dovetails, just stamp them. It takes seconds. And yeah, it sounds pretty awesome. I don't think I'll be doing a buttload of dovetailing. This is more just for like little stuff. For main production, we're not going to be doing it. But I see the benefit of a stamping machine, faux show. Cool, okay. But this one's wrong, so we got to redo it. So I'm going to open it up. That's stupid. I need this. This is why it comes with this, with the knurled thing. Okay, so this one side is wrong because it's off center, right? Man, this piece is magnetic. I can feel it stick. I do have a demagnetizer. Yeah, that might be deep enough. We'll see. I'll throw it in CAD and I'll see if that's deep. It should be deep enough. We'll see. I might have to space it up just a little bit. More like that might make me a bit more comfortable. And this is one of those moments when it's like, it should work, but I don't know. So this is the final pass in this new orientation. Look how close that gets. Oh no, I don't think so. I don't think that's happening. It could, it should. It should theoretically work, and Camplete will verify that this will theoretically work, but oh, that's like the pucker factor. Oh. I don't know, I might need to space this guy out just a little bit, put a little shim under there, a little parallel. Yeah, I'll just do that, and then I'll be happier. Close though. I guess I don't want to. What I could do is I could cut down just halfway here and then flip it over and cut down the same on the other way, but then I'm wearing just the bottom of the tool instead of kind of the full flute length. It's always nicer to wear the full flute length if you can, but if I did that, that would give me plenty of clearance. So lots of different ways to do it, right? Haha! That's all I need. Maybe I'll go for that set. There we go. So that's what it looks like now with the 1/2 inch parallel. Plenty of clearance there on the final cut. And then if we skip to the end, boom, we got ourselves a dovetail. So I noticed when I tightened it and when I torqued down the vise, this got a little wiggly. I don't use these very much, but I've certainly used them enough and read enough and heard enough from other machinists, and I know we're going to get a lot of great comments in the comment section. I know some people like to put the shim in, put your stock in, and kind of hammer it with a dead blower or a rubber mallet or whatever. I forget if you hammer it while you're tightening or just once after you tighten or something, but either way, it was fine for me to pull this out. And this is a roughing operation, so it's no big deal. But I also don't really want to leave this in the machine with it all flying around and everything. Also, I don't really want to be hammering on this 5-axis machine. So for that reason, I'm out. It's out. Do the same to the other one. So while I load it, tighten, then it comes out. Oh, you know what that noise is? That noise is this guy just finished. 53 minutes. That's a really long time just to do a pattern. Okay, I don't know, man. I still see some chunkiness in there. Back here, it's great. Sorry if I wasn't aiming properly. Back here it's great, but up here there's still some feathering and I can feel it. I gotta try something else. That didn't quite solve the problem. It did here. Okay, I'll figure something out. Can't have it looking gross though. Well, I think I've done it. I think I've written the code that I need in order to run multiple pallets. It's very rudimentary, very basic, but simple. So in the program management thing, you have your Heidenhain files are always .h, that's your G code, and then if you create a file called .p, it's this. It's a small little spreadsheet. So all I'm doing is I'm calling pallet number 14 and I'm running program 1001. Calling pallet 12, running the same program 1001. 14, 1001, 12, 1001. This pallet parks in 14, 12, 14, 12. And the way the pallet changer works is, if you see that blinking light over there, now it's locked, I can't open it, it's ready to work, so I can't get in there while it's working, and while I'm in here messing around, the machine can't use the pallet changer. So it's safe, it's great. Even if that's done and waiting, it's gonna wait for me until I close the door and push that button, and then it's gonna auto-load the pallet. So it's a pretty sick system. And that's a lot easier than I expected it to be. That's dead simple. So I think if I go to, I'm in the table editing screen, I think if I go to that screen and run Grimsmo, Dovetail, select, I think if I just run that, it'll work fine. Now, the Kern guys were telling me about an upgrade you can get for Heidenhain for the computer control that is like pallet scheduling on steroids. So not only can you do the very basic features that we just showed there, but it can look ahead at what pallets are coming up. It can look ahead at the tool life, at what tools, like how much tool life do I have left so that I know I can run all of these pallets, otherwise I'm going to flag an alarm. It makes it very easy to reorganize and sort pallets, because dude, I've got 80 pallets on this machine, 25 big ones and 55 baby ones. So the sooner I can get this thing running a lot of parts, the better. And with that upgrade, like I said, you can reorganize and resort easily which programs are running next and what pallets they go to and what code is running and all that stuff. While the machine is running the same program. Whereas I won't be able to edit this code, today's code, while it's running. But I think that upgrade he said was $4,000, which is like mad Skrilla. I don't know. I'll probably end up getting that eventually once I find the need, because that sounds awesome. That sounds super awesome. So like, I want the scenario where there's like hard stuff and there's cakewalk stuff that's run on this machine. And the cakewalk stuff, I want to come in the morning, there'll be finished parts, I want to load new parts up, and I want to tell the computer, oh, I just loaded that pallet. And then it's just going to do it. And it's still going to be running from the night before, and now I've rescheduled, this pallet is now loaded, so it's okay to run it again. Yeah, so I got some more learning to do there, but I'm really looking forward to that update if and when I do it. All right, I think we're ready to run the multi-pallet sequence. So I've put both the pallets back in the pallet changer. There's nothing in the spindle right now. I've got my code up. It's going to call pallet 14 first, which is the one that's loaded. Pallet 12 is not loaded yet. I think this is going to work. Goggle up. Okay, that rotated. Yep, robot's grabbing the pallet. Okay, okay. Pallet's going in. So now once the door closes, there it goes. It should call a different tool. No, it says, I got an error. It says wrong pallet. I don't know what that means. I don't know. It says wrong pallet. I'm confused because it clearly called the right pallet. It called pallet 14. It doesn't say wrong code. It says wrong pallet. Maybe I typed the 14 in wrong. Alright, I think I figured it out. I did some research on my phone. I found a great PDF article online going through. So you got your, like I was saying before, you got pallet 14, program 1001, pallet 12, program 1001. Except over here in location, we got to add this MA. It only has two options, nothing or MA. MA, according to the article I read, means like manual pallet, which is kind of weird, but it does not work if that's empty. It does work if it says MA, so I think it works. And then it started working already, so we'll see if that works. Now that we have it centered properly, because I'm in the faces of the jaws, when it cuts the left side and it cuts the right side, especially the first few passes, it sounds right. They sound the same. Going good. So now I gotta load up this pallet so that hopefully it's done by the time this one's ready. I still got to come in and deburr, head to the grinder real quick. So I got the pallet, the Aroa door open, so it should just wait. So I'm gonna go do this and it should just wait for me. So this is our little grinding, scotch-brighting, drilling, messy area in the back of the machine shop here. And something I really want to set up, or have the guys set up, is a dust filtration setup. So a lot of knife makers will have like a suction tube with ducting to the suction vacuum cleaner, whatever you're using, so that every single spark and dust that goes down off the grinder or off the belt or off the Scotch-Brite wheel has like a catch and then suction tube away, because the ground gets a little dirty and we sweep it up every day, but all that dust should just disappear at the source immediately. So that's kind of been on our long-term to-do list. However, it's time to get it going. Now we wait and see. Should be almost done. Oh, it's happening. Okay. Robot's going in. Oh yeah. Okay, so it's going back to 14. That's good. That should go over to 12. Yes! Oh, I'm so excited right now. Yes, baby. That's cool. That's my first automatic pallet load. What am I looking at? I mean, I think I'm spending 8 minutes to cut a dovetail, which is ridiculously long. I'm going super light cuts, 10,000 step overs. I will get faster over time, but the fact that it works is sweet. So, like I was saying earlier, this goes to show that everything has to be right. Everything has to be exactly what the computer thinks it is. I can't, you know, when I'm putting the parallel, the shim underneath, if the material is higher and this is like super loose, then now my material is, you know, X amount higher than what it's supposed to be. So the first cut might be too heavy. There's a lot of things to think about. So process control, make sure everything's the way it's supposed to be. Make sure when I put the material in the vise, it's centered left to right. Right now I'm just eyeballing it because I know there's some extra room here. Also, like I was saying in my last video, all this material is completely different sizes. Can't see it. You know, the thickness is almost all the same, but the height and the width of all of them are variable. So I went through, you know, the 6 or 7 that I'm going to run right now, and I found the biggest one and that modeled the biggest one. So that's what I'm basing everything off of. It's good, that's good. So I just loosened it off. Now I can pull it out. There's not that many chips on it, but it is wet. There's a few chips, like I said, it's magnetic. So there's a few chips hanging to the bottom, and I'm dripping here. Good, 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 good. Let's grab the next one. Again, I gotta deburr this one now, and I gotta make sure there's no chips inside here, so when I put it back in, it's good. Okay, let's try this out. While I was deburring all those parts, the machine finished, so let's close the door, push the button, and it should activate. Yes, it does. I think. Yeah, it's been thinking. So now it's going to put back 12. Ooh, going so good. And then it's going to grab 14. And on and on and on. You can see where it's at. It did the first 14, then it did 12, now it does the second 14. And I had to write how long this code is. So I did 16 blocks. So I think I did 8 pallet changes. Look at the difference here in, whoops, in stock length. If I line up the back, look at that guy, it's so much longer. I bought the same material. This is just how it was cut. So I had to plan for the biggest size, very important. So I've been having fun getting the Swiss lathe to run for the night. There's a bit of a problem running these long plastic bars. As the bar loader was loading the bar forward, the bar fell into this channel where the remnants go, the scrap pieces, and it bent the bar, and the arm thingy came down, and the flag, this is the flag, got stuck and bent. So I gotta bend this thing back right now. That is not straight. If this is vertical right now, that guy's not horizontal. Luckily, this is the only thing that bent, nothing broke. Yeah, loading those plastic bars is tricky. I haven't found a way yet to auto load them. I'm loading them each by hand, which kind of sucks, but I'll figure it out. Anyway, bend that back. I don't know, I got a bunch of stuff to do before I go, but I'm gonna end this here, and I will see you guys next time. Thank you very much. Bye.